Dear friends, so far we have studied about the importance of chemistry, significant figures, and scientific notations. Friends, in your previous classes, you have learned about the law of conservation of mass and law of definite proportion. You all must be having a little idea about that. Let us learn more about laws of chemical combinations. The combination of elements to form compounds is governed by the 5 basic laws. These are law of conservation of mass, law of definite proportions, law of multiple proportions, Gay-Lussac's law of gaseous volume, and Avogadro's law. Now let us explore each of them one by one. The first one is law of conservation of mass. It was given by Antony Lavoisier in 1789. Children, we must appreciate the work done by the great scientist. Antony Lavoisier performed careful experimental studies for combustion reactions and reached to the conclusion that in all physical and chemical changes, there is no net change in the mass during the process. Hence, he reached to the conclusion that matter can neither be created nor destroyed. This is called law of conservation of mass. Let us perform an experiment to verify the law of conservation of mass. Friends, you can see the material required for this experiment. We can use digital balance or spring balance. We require sodium hydrogen carbonate. I have already measured 100 milliliter of acetic acid and I have taken it in a conical flask. We require one balloon and a spatula. First of all, I will take sodium hydrogen carbonate in a balloon. We will take around 1 gram of sodium hydrogen carbonate in a balloon. Now, after taking sodium hydrogen carbonate in a balloon, we will add acetic acid in a dry conical flask. It is 100 milliliter of acetic acid. And while handling the chemicals, children, remember you have to take all the precautions. Okay. Now, I will fix this balloon on the mouth of this conical flask in such a manner that the sodium hydrogen carbonate remains in the balloon. Now, I will measure the weight of this conical flask with the help of this spring balance. You can use any other balance also. Now, let us see what weight is coming here. Now, if you will see, it is coming 2 gram. Now, children, carefully I will keep this here and now I will add the sodium hydrogen carbonate which is in the balloon to the acetic acid and let's see what happens. Now you can see the reaction is occurring and carbon dioxide is produced and you can see the balloon. Wow, very good. Very interesting. Children, now I will weigh again this with the use of spring balance. Amazing. The weight is not changed. It is 2 gram again. Now it proves that the mass before the reaction and the mass after the reaction is same. So we have verified the law of conservation of mass by this simple experiment. You can perform this experiment in your lab under the guidance of your teacher. Friends, we have verified the law of conservation of mass. We have seen that mass before the reaction and after the reaction are same. So, mass can neither be created nor destroyed. Let's see what is law of definite proportion. This law was given by French chemist Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. Proust worked with 2 samples of cupric carbonate. One was of natural origin and the other was synthetic. He found that the composition of elements present in it was same for both the samples, as you can see on the screen on the table. Percentage composition of copper, carbon and oxygen are the same in natural sample and synthetic sample. Thus, he concluded that irrespective of the source, a given compound always contains same elements combined together in the same proportion by mass. Now let us discuss the next law of chemical combination. It is law of multiple proportion. It was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combined with the fixed mass of the other element are in the ratio of small whole numbers. For example, hydrogen combines with oxygen to form two compounds, water and hydrogen peroxide. You can see on the screen when 18 gram of water is formed, 2 gram of hydrogen combines with 16 gram of oxygen. When 34 gram of hydrogen peroxide is formed, 2 gram of hydrogen combines with 32 gram of oxygen. Here, the masses of oxygen, that is 16 gram and 32 gram, which combined with a fixed mass of hydrogen, bear a simple ratio, that is 16:32 or 1:2. Friends, I know you all will be curious and excited to learn more examples of the same. So, search some more examples where law of multiple proportion is obeyed. Let us discuss Gay-Lussac's law of gaseous volume. It was given by Gay-Lussac. He observed that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at the same temperature and pressure. So, when 100 milliliter of hydrogen combined with 50 milliliter of oxygen, it will give 100 milliliter of water vapor. You can see on the screen 2H2 plus O2 gives 2H2O, and the volume also 100 milliliter hydrogen, 50 milliliter oxygen and 100 milliliter of water is forming. Friends, another law of chemical combination in which we will see a relation between volume of gas and number of molecules is Avogadro's law. According to this, equal volumes of all gases at the same temperature and pressure should contain equal number of molecules. If we consider again the same reaction which we have seen, H2 plus O2 gives H2O, we see that 2 volumes of hydrogen combined with 1 volume of oxygen to give 2 volumes of water without leaving any unreacted oxygen. Let us all be thankful to John Dalton, whose atomic theory provided scientists with the new ways of seeing the physical world. The main postulates of Dalton's atomic theory are: matter consists of individual atoms. All atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combine in a fixed ratio. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Friends, let us assess ourselves. Find out the answers of the questions displayed on the screen. The first question is, the following data are obtained when dinitrogen and dioxygen react to form different compounds. Mass of dinitrogen, you can see in the first case it is 14 gram, mass of dioxygen 16 gram. Second case, mass of dinitrogen 14 gram, dioxygen 32 gram. In the third case, mass of dinitrogen 28 gram and dioxygen 32 gram. Fourth case, mass of dinitrogen 28 gram and mass of dioxygen 18 gram. Now, here you have to verify which law of chemical combinations is obeyed by the above experimental data, and you have to write its statement also. In the second question, if 10 volumes of dihydrogen gas reacts with 5 volumes of dioxygen gas, how many volumes of water vapor would be produced? Friends, though chemical reactions can be complex as they are numerous, They are all fundamentally governed by these same laws of chemical combination, which lay the groundwork for analysis of chemical reactions. They are the launch pad from which we jump off to creating all sorts of compounds and phenomena. So, now you will be able to appreciate various laws of chemical combination. You will be able to explain combination of different atoms and molecules. You will be able to plan and conduct investigation, experiments to arrive at and verify the laws or seek answers to queries of your own. You will be able to take appropriate precautions while handling apparatus and chemicals during the laboratory work. Now, you will be able to calculate using the data given. Appreciate the contribution of scientists. Exhibit the value of honesty while recording and reporting, as we have done the experiment. Whenever you are doing the experiment, record your observation honestly. You will be able to communicate the findings effectively. You can make efforts to keep the environment clean. Friends, solve the questions given in your book. Read more about these laws from the sources available and experience the inspiration which we get from the remarkable work done by the scientist. Friends, so far we have learned about the importance of chemistry, significant figures, scientific notations, laws of chemical combinations, atomic mass, molecular mass, formula mass, mole concept and limiting reagent. Now, we are going to discuss about the concentration terms. Friends, we know that a majority of reactions in the laboratories are carried out in solutions. Therefore, it is important to understand how the amount of substance is expressed when it is present in the solution. The concentration of a solution or amount of substance present in its given volume can be expressed in any of the following ways. First one, mass percent or weight percent. Second, mole fraction. Third, molarity. Fourth, molality. Let us now discuss each one of them in detail. Mass percent can be calculated when mass of solute is divided by the mass of solution multiplied by 100. Now let us solve a numerical to make our concept clear. A solution is prepared by adding 2 gram of a substance A to 18 gram of water. Calculate the mass percent of the solute. Here you can see we know the formula of the mass percent. So if we want to calculate the mass percent of A, we will write mass of A divided by mass of solution into 100. Here A is 2 gram. So we will write 2 gram divided by 2 gram of A plus 18 gram of water, because we want the mass of the solution, multiplied by 100. After that, we will get 2 upon 20 into 100 and the result is 10%. Next concentration term is mole fraction. Student, let us consider a substance A is dissolved in the substance B and their number of moles are Na and Nb respectively. Then the mole fraction of A and B are, mole fraction of A is number of moles of A divided by total number of moles. So what are total number of moles here? Na plus Nb. In the similar manner, if we want to calculate the mole fraction of B, it is number of moles of B divided by total number of moles in the solution. So it is equal to Nb divided by Na plus Nb. So mole fraction is the ratio of number of moles of a particular component to the total number of moles of the solution. Friends, now we are going to explore most widely used unit for concentration, that is molarity. It is denoted by capital M. It is defined as the number of moles of the solute in 1 liter of the solution. In the formula form, you can see on the screen, it is represented as molarity is equal to number of moles of solute divided by volume of solution in liters. Suppose we have 1 m solution of a substance. We can consider sodium hydroxide and we want to prepare 0.2 molar solution from it. So first we will do the calculation. 1 m NaOH means 1 mole of sodium hydroxide present in 1 liter of the solution. For 0.2 m solution, we require 0.2 moles of NaOH dissolved in 1 liter of solution. Hence, for making 0.2 m solution from 1 m solution, we have to take that volume of 1 m NaOH solution which contains 0.2 mole of NaOH and dilute the solution with water to 1 liter. Now, how much volume of concentrated NaOH solution be taken which contains 0.2 moles of NaOH and which can be calculated in the following manner. If 1 mole is present in 1 liter, or we can say 1 mole is present in 1000 milliliter solution, then 0.2 mole is present in 200 milliliter. Thus, 200 milliliter of 1 m NaOH are taken and enough water is added to dilute it to make 1 liter. Friends, let us perform an experiment to prepare m by 10 oxalic acid solution. Friends, to prepare m by 10 oxalic acid, you can see the material required. We need digital balance, watch glass, oxalic acid, wash bottle, funnel and a volumetric flask. In the volumetric flask, you can see there is a mark. If we will fill the liquid up to here, it will be 1 liter. Okay children, let's start the experiment. First, we will weigh the weight of this watch glass through this digital balance. First of all, I will check that it is at 0 point or not. It is at 0 point. So, I will keep this watch glass on this and I will see what is the weight of this watch glass. I will record this in my notebook. To prepare m by 10 oxalic acid, first of all, we have to do the calculation. We have to find out how much gram of oxalic acid is required. For this, we will use the formula. We have already learned molarity is equal to number of gram moles of solute divided by volume of the solution. Here, molarity is 1 by 10. Volume is, we are going to prepare in 1 liter. So, 1 liter is the volume. We know the molar mass of the oxalic acid. Children, you have learned how to calculate the molar mass. The formula of the oxalic acid is C2H4O2.2H2O. The molar mass of the oxalic acid will come 126 gram. You will put this value in the formula of molarity and you will find out what is the mass of oxalic acid required to prepare m by 10 oxalic acid. It will come 12.6 gram. Children, with the help of digital balance, you will weigh 12.6 gram oxalic acid. Here, I have already weighed, it is 12.6 gram. So, now I am going to prepare oxalic acid of the molarity 1 by 10. First of all, I will take a funnel. I will put this funnel on the volumetric flask and slowly I will add this oxalic acid into the volumetric flask. Now children, whenever you are handling the apparatus, always take precautions and you have to keep in mind that the particles of the oxalic acid do not scatter on the table or on the digital balance. Now, we will wash this watch glass so that all the particles of the oxalic acid comes into the volumetric flask. Next, we are going to add water to it. We will wash this funnel also so that all the particles which are there on the wall of this funnel will come into the volumetric flask. Now keep in mind, whenever you are adding this water for washing funnel or watch glass, do not use water more than 50 milliliter. Okay, after this children, I am going to add more water to the volumetric flask and after this, I will swirl it so that oxalic acid can dissolve into the water. Now, I'm going to add more water to it and I will make it up to 1 liter. Children, whenever you are doing experiment in the laboratories, always take care that you have to use the chemicals and handle the apparatus carefully. Now, while adding the last few milliliter, children keep in mind that we have to add it drop wise so that it should not come over this calibrated mark. Now we will add drop wise. You can see I am adding drop wise and it is up to this mark. So, in this manner we have prepared M by 10 oxalic acid solution. After this, you will put its cover and label it as M by 10 oxalic acid solution. Friends, while preparing the oxalic acid solution, swirl it properly so that oxalic acid dissolves in the water. Friends, now task of the day. You have to prepare M by 10 sodium carbonate solution. You know the formula, you know the calculation, try it by your own. Now, the next concentration term is molality. It is defined as the number of moles of solute present in 1 kg of solvent. It is denoted by small m. In the formula form, it can be represented as molality is equal to number of moles of solute divided by mass of solvent in kg. Friends, here I want to discuss a very important point that molarity is temperature dependent whereas molality is temperature independent. Do you know why? Molarity is temperature dependent because volume of solution is temperature dependent, whereas molality is temperature independent as mass remain unaffected with temperature. Let us solve a numerical. The density of 3m solution of sodium chloride is 1.25 gram per milliliter. Calculate the molality of the solution. Children, here molarity is given 3 mole per liter. Mass of sodium chloride in 1 liter solution will be 3 multiplied by 58.5. Now, from where this 58.5 has come? Yes, you have calculated the formula mass. It will be equal to 175.5 gram. Mass of 1 liter solution, it is equal to 1000 into 1.25, which will be 1250 gram. Since the density is 1.25 gram per milliliter, mass of water in solution, it is equal to 1250 minus 75.5, which is equal to 1074.5 gram. We know that molality is equal to number of moles of solute divided by mass of solvent in kilogram. So, it is equal 3 mole divided by 1.0745 kg. It is equal to 2.79 molal. Task for the day. Solve the numericals displayed on the screen. The first one is calculate the mass of sodium acetate required to make 500 milliliter of 0.375 molar aqueous solution. Molar mass of the sodium acetate is 82.0245 gram per mole. Second numerical is calculate the concentration of nitric acid in moles per liter in a sample which has a density 1.41 gram per milliliter and the mass percent of nitric acid in it being 69%. Do the back exercise questions related to the topic and try to solve more numericals for better understanding of the concept. Now children, you will be able to calculate molarity, mole fraction, molality and mass percent of various solution. You can differentiate between molarity and molality. You can measure physical quantities using appropriate apparatus. You can communicate the findings and conclusions effectively. Children, you can plan like this and conduct investigation, experiments to arrive at and verify the laws or seek answers to queries of your own. Take appropriate precautions while handling the apparatus and chemicals during laboratory work. Children, calculation using the data given will be a simpler task for all of you now. Appreciate the interface of chemistry with mathematics. Appreciate the contribution of scientists. Exhibit the value of honesty while recording and reporting. Children, after learning some basic concepts of chemistry, analyze the result as well as accurately record your observation. Explore new areas of research. Do investigatory projects under the guidance of your teacher. Try to do group activities. It develops patience. Share your views to others and listen to others' points of views also. Collaborative learning helps you in the holistic development and ultimately it will help you to be a good citizen. You know, problems related to environment is a big challenge, particularly for chemists. So, as a chemistry student, make efforts to conserve environment. Thank you.